Welcome to a demonstration of the reinforcement learning project with the Raspberry Pi Sensehat. The Sensehat comes with an 8x8 matrix of LEDs and a couple of sensors, like a 3D acceleration sensor and a 3D gyroscope. As you can see, there is one red dot, on the matrix running around as part of an interesting reinforcement learning exercise. The Raspberry Pi is talking with a MacBook over Wi-Fi. It is sending the accelerator and gyroscopic data. The MacBook is filming the Raspberry Pi with its built-in webcam. The task of the agent will be to put the red dot in the middle of the image. If the Pi is moved, the agent has to take action in order to keep the red dot in the middle of the image or as close as possible, if the center should be out of reach of the matrix. With all these elements, we can create an environment where the state space is an 8-dimensional floating point vector. 8 floating point numbers, which are the x and y position of the red dot in the image of the webcam, 3 values that measure the acceleration of the Pi in the x, y and z direction, and 3 values for the gyroscope of the Pi, also known as pitch, yaw and roll. The action space is discrete, with only 8 actions. The agent can move the dot 1 pixel in each possible direction, that is up, down, right, left, and then the 4 diagonal directions. With this environment, I trained a DQN model of stable baselines, with an MLP policy that consists of the default setting, which is 2 layers of 64 nodes. The reward function is minus the distance to the center. This way, the agent gets rewarded for keeping the red dot right in the middle of the webcam image. Because training takes some time, I mounted the Raspberry Pi on a car mobile phone holder. You can easily attach these things to glass, so I took a vase to mount it on. The mobile phone holder can be turned around so the model can learn the task in every position of the Pi. But I don't have to hold it in my hands during 8 hours. I can still go and have a coffee, which doesn't mean I can let this Raspberry Pi rest for a long time, because I have to continue moving it and shaking it so the model can learn what is the influence of the accelerator and the gyroscopic data on its performance. And that is exactly what I did for the last 80,000 steps, which is about 7 hours. As we can see on the tensor board, the episode awards is going up. That means the model is learning. Each time I start shaking the Raspberry Pi, this curve goes down a little bit, but then afterwards it climbs again. The importance weights are descending steadily, the rewards keep on climbing, and the loss is a descending curve towards 0. All signs of a learning model. And as a result, we see that the model learned almost perfectly to follow the center of the image with the red dot. Even if the Raspberry Pi is turned around, the red dot is still chasing the center. As this model is still learning, it has limited episodes of 50 steps. You will see the red dot jump to a random position at the beginning of a new episode. But from there, it runs as fast as it can to the center of the image. And the remarkable thing is, the more I train this model, the better it gets in doing this.